Okay. So you'll notice the two parts that we made yesterday, part one and part two. Now, what we are going to do is basically this thing. Now you'll notice that this pipe has been attached to this plate over here through this hole. You can see the hole over here. And before we get into the assembly, one thing that is actually related to part design is addition of materials and other properties. Now you'll notice that previously yesterday we didn't do anything of the sort with relation to these parts, but over here, let's say you have this part, for example. Now, in case I want to see, let's say, the weight and everything, when I right click, I'll get a, or yeah, I'll just show you the part file itself. So it'll be easier to understand. Yeah. So if let's say I have this part over here. Now this part is under this body one entity. So if I right click on this, I'll get a lot of stuff over here like physical material appearance and etc. Now this option properties shows you the total area like surface area, the density, the mass of the part, volume, etc. Now by default, Fusion 360 assumes steel. So that's why the physical material over here is steel. And of course, you have other stuff like the moment of inertia and everything. These are really advanced properties which not you may not require it much, but it's good to know that it's there. And you can also copy those properties to a clipboard and put it in a text file or say an Excel sheet in case you're doing some calculations regarding them. Now, in case I want to change the physical material, I right click on this body one and I go to physical material. This will give me a, you could say, a library of inbuilt materials with their properties that Fusion 360 has. Now, let's say I select another form of metal. These are all the different forms of metal that are there. And let's say we select aluminium. So let me just double click that. And so So what I did right now was drag and drop, and you notice that the part itself has changed color a bit. So let me just show you for reference. So this is when it was steel, and this is when it is aluminium. This should be easier to see. So this was steel and this is aluminium. Now, of course, you can apply other materials also, like let's say we apply glass. So let's take this bronze glass. And then we bring six to the. Now you notice that the part has become transparent because after all it is glass, so it's see-through. And of course, you will notice a bit of a brownish tinge over here. So that is because I applied bronze glass to this. So just for reference, this was steel, this was aluminium, and this was glass. Now the same logic applies over here to the assembly that I did. You can either uh, apply the material to the part itself and then put it inside your assembly, or you can put the part in the assembly and then over there itself you can change the material whatever you like. And this is one aspect of Unity 360 which is actually good, changing things on the fly, because with other CAD software you have to uh, predetermine things before you actually kind of import them into your file per se. Okay, so one thing that you'll notice is that body 1 and body 2 are in separate files and the assembly has been done in a separate file altogether. Now, this is not required. You can actually design both parts and assemble both of them in one file itself. And that is also one very good aspect of Fusion 360, where if you're for other CAD softwares, you would have to like design separate parts and then you have a separate assembly file where you import those parts and then you assemble everything. But with Fusion 360, you don't need to do that. You can create both parts in the same file. So yesterday, body 1 and body 2, I could have made it in the same file. And then today I could have assembled them in the same file. Now, how that is done is you will notice here that body 1 and body 2 have this square, this cube icon next to it. Now, the cube icon is used to denote a component. Now, what is the difference between a component and a body? If you take, say, any random part that you're making, any random design that you're making, that design can have lots of features like lots of extrusions, holes, and etc. And each, you could say, feature that you're making that counts as a body. Now, let's say you have this set of bodies that you've designed, and you want to you have another set of bodies, like let's say three bodies in one set in set A and three bodies in set B, and you want to kind of group the six of them together in two, three, and three. So components are a good way to do that. And when you make a component, the it's essentially like you're making a separate part file in, say, another CAD software. And let's say that I have this empty file over here in which make I want to make my assembly. Now, like I said, you don't have to do this. You can do it in the same file. But the reason why I'm showing this workflow is, first of all, in case anyone's come from other CAD softwares, this might feel more familiar, like designing different part files and assembling them in a separate file. And also there are, you could say, some differences from the original, you could say, single file workflow, in that because you've designed each part separately, the version control for each, you could say, part, or yeah, each file is independent. If you recall day one where we showed the design timeline, the design timeline is the design process over the entire file. So if you say have multiple, let's say, bodies or components, the timeline will cover everything. However, in case you want a more, you could say, hygienic and a clean workflow, you can design separate files as well for the parts. Another way to, so you it kind of loophole through this is you can use components inside a single file. And like I said, a component is like you're designing a part file by itself. So each component has its own design timeline. But once again, everyone has different workflows. So this is just one of the workflows I've shown. And of course, there are the other ones that I talked about. Now, also one advantage of, you could say, this workflow that I'm talking about is, obviously, as a CAD designer, you may not be designing everything from scratch. Like, say your whatever you're designing has some nuts and bolts, some screws, whatever. Obviously, you wouldn't be designing every single nut and bolt, right? And of course, there are libraries online or resources online from where you can get these things pre-made, like how you have Stack Overflow for computer code. So more often than not, those resources, whatever you download, say you are downloading a design file for a nut, and obviously it'll come in a separate file. Now, how do you get that file inside your Fusion design? Now, with other CAD softwares, there's a very long drawn process where there's this option saying add a new part, then you have to locate that wherever the file is in your computer, and then it gets added into your system, into your file. But over here, for Fusion, it's as easy as dragging the file from here and leaving it as it is. You just wait for a minute to update. There you go, simple as that. So there's no additional tools required, nothing. It's just simple drag and drop. Of course, you can also add stuff from other say files as well. So let's say I have this assembly file here, and let's say in the beginner, let's say I want to add something from the first folder. I can also do that too. Now, what this does is, you'll notice this link over here, this little chain icon. This denotes linkage. Now, what is linkage in terms of, it's more of a data management term, and essentially any changes that you make to the file, let's say go over here and let's say I make this a bit wider, I make the plate a bit wider, that the change that I made in that part file will be updated over here. So, and also one more thing is it won't update automatically. There you get this little icon up here that says update latest changes, which as the name suggests updates all the latest changes that you've made to each file. So let's say you've just dragged and dropped your first component of your assembly, your first part of your assembly. This little menu opens up, and this is called the Move Copy tool. You can access it using M on the keyboard for any other part in the design. And what this does is, like the name suggests, you can move and drop your part anywhere you want. So I'll just press OK for now, and this is my part at the moment. Now, if I want to add the second part, I can do the same thing, drag and drop. And once again, I can use the move copy tool and set this aside a bit. So these are the two parts that we've imported, or you could say just put into our design. And you can change the material up to you. It's up to you. I'll just change the material right now. Okay, the color is a bit too much. Okay, I'll just leave this as it is. So I've applied the material, or you could say the appearance, to just one part of the assembly. Now that you've uh, imported, or you could say gotten both the parts, what we need to do now is apply constraints. Now, once again, you have constraints in design, in sketching, you have constraints as assembly also, because technically speaking, these two parts are still unconstrained, just floating in free space. And now for assembly, obviously, when we make any assembly, or even when say you say draw anything in let's say physics, you have a free body diagram in physics, right? It's customary to include a reference point, or in other words, something like a ground reference or a ground link. So let's say I want to ground this, I want to make this the reference for all my whatever assembly that I'm doing. So I can go here, and when I right click, I'll get this option called ground. Now when I click it, now you'll notice that this pop-up might come up. Now what this actually is referring to is this portion. Now you'll notice that when let's say you've just put your parts in, and this won't come. When you just put your parts in, this thing might not come. Yeah. So you'll notice that this thing has disappeared. Now if I move this a bit, you'll see that this, you could say this panel appears. Now what this actually means is it's a way to record what the current, you could say, configuration or positions of the parts in your design file are at this moment. And how this is useful is, let's say you want to, let's say, show another person that the assembly that you made in this specific configuration, like let's say the pipe is over here, let's consider this as one configuration. You want to show the other person that in this specific configuration there is some problem, like maybe the holes are aligning up or something like that. So you you can save the file, or but if you save the file, this doesn't get recorded, or in other words, it goes back to the same you could say position, because you've not you could say frozen this thing in place. And this capture position tool is a good way to do it. Now position tool, it came on the timeline because this is technically a design process that I just did. I recorded the position of this material, and I can change the position again, capture the position again. And let's say I change it and I don't want to capture this position. I can use the other tool. which is revert. So it reverts back to the previous position. And using these tools, the capsule position tool, I can sort of see what different configurations, let's say another designer wanted to describe to me or show to me, rather than just like saying with words that, okay, this part has to be put here and there's a problem over there. So he can move the part where he wants to, select the capture position tool, and then later on when I am seeing this design, viewing this design, I'll be able to see what changes he's made or what uh, changes he wants me to show, wants to show me. Okay, now to make assembly, now that we have to first ground the link, ground this part, you notice that this pin icon comes, and also this will come on the design timeline. So once again, this is another design process that I did. I established one of the parts of the assembly as a reference link, as a ground, and this thing is still moving around, and obviously you have the capture position tool. This won't move at all because it's ground. Now what I want to do here is I want to align this hole, this specific hole, with this one. So you can probably visualize what's happening here. When I align this hole with this one, this pipe can revolve or rotate around that point. And how I do that is using the joint option. Now the default option in the toolbar might be as built joint, which I'll come to later. You'll find joint in the drop down under assembly. And of course, the keyboard shortcut is J. So I selected J, and obviously because I changed the position, this pop-up comes up. So I'll just revert to the previous position. Now you'll notice that this panel is now listing all the components that are over here at this moment. Now I can choose to say deal with, if let's say I have four or more components, I can choose to deal with just two, because when you when this is more of a theory based thing, but when you make an assembly, a joint is essentially a relation between two bodies, right? Like if you say take a door and a door frame. Now there's just one relation that you can make between the door and the door frame. The relation where the door rotates about a single point in the door frame. And the same logic applies here. So if let's say I want to construct a joint or a relation between this hole and this hole, I'll first have to snap. I'll have to select this portion. Now you'll notice that if I select the edge, this thing over here, that is the center of the joint that I'm making. Now this is the, you could say, the center of the joint that I'm making, and depending on what part or what thing you're actually selecting, the center of the joint will differ depending on the entity that is selecting. Like in this case, I'm selecting the whole pipe, so the center came up over here. Since I'm selecting this edge, the center came up over there. Now I want the center of this joint to be about this axis, the axis that this hole is passing through. So I'll be doing this. Okay. And now for the next component, the next joint, I'll be selecting this. Now, obviously, depending on what portion of the face I'm selecting, the center of joint will come there. But since I want the joint to be aligned with respect to this, I'll select this. Now you'll notice that I'll explain what's happening here right now. When you assemble a joint, what Fusion does is it automatically snaps, or you could say brings the two components together at whatever joint you've made, and it does a little animation to show what type of joint it is. In this case, what I've done right now is a rotation joint, or in technical terms, a revolute joint. And over here you have lots of other different joints that you can do, like say rigid, in which case this will is going to be, it's kind of like the fixed constraint, in that you're fixing these two bodies together, they're not moving. Then you've got the slider and cylindrical. So this is kind of like a screw joint in a way. And you have lots of other stuff too. So depending on what move motion you want your two parts to do, you can select the corresponding joint. So in this case, I just want a revolution. I just want a rotation. Now you'll also notice that this part is clipping through the plate, and that is because this option over here, flip, is enabled. And what this does is, obviously it does happen that the software doesn't really understand intuitively how things are supposed to be arranged. It just, what I just did was I just selected this hole and this hole over here. So it just understands that it has to bring it together. So it won't understand intuitively that we're supposed to place this on the other side. So this flip option is a way to tell Fusion that, okay, we wanted it on the other side. And of course, like I mentioned, you can either change the type of joint over here, or you can also use the motion tab over here to see what type of joint you actually want to put. And of course, depending on what type of joint you are making, you can have different axes for it also. And there's also this animate function in, so that you can just see and take a look at what, how the thing is actually moving. So I'll just press OK, and you'll notice that the joint feature has come in the timeline and this little flag has come here. Now, in case I want to try to move this, because this body is, you could say, bound to this ground link through this joint, through this rotation joint, rotatory joint, any attempt to move this body will cause this to rotate. And you can see this little angle icon changing, the icon graphic. So at the moment it's 89. So I'm going to negative. And this is also a very good very good feature that Fusion has, in that other CAD softwares, this actually isn't there, or rather it's not to the extent that Fusion actually has. There's a separate tool for actually doing this stuff, this moving that I'm actually doing right now. But in Fusion, it's all intuitive. It's already inbuilt into the UI, the workflow. Now this is your design, and so this is your assembly, and that's it. It's as simple as that. There's no fancy stuff that you have to do. Now in case I want to, let's say, change the position of this joint, let's say I want to say link this hole to this hole, so I can once again edit the whatever joints, that whatever portions that I want to make a joint out of. And you'll notice that this snap portion, which is what I was talking about, it'll snap that hole to this hole. That is already selected because obviously I'm editing an already made joint. So I'll just deselect that. And then when I select this, once again it'll snap to the position, and then it'll do the little animation. And I can repeat this for any other hole. Let's say this one. So once again it's flipped. So I'll just flip this again. And that's it for design. Now, now that you've assembled this assembly that you made, now you can obviously you can do the capture position thing here also, because like I said, it's a different configuration, uh, technically speaking. So you can capture this position. I can rotate this a bit more, capture this position, and so on. Now, in case you want to, now you can, what I'm doing here is I'm basically eyeballing how the thing is moving. But if you want a detailed study of how this thing is rotating or how this thing is interacting, like visualize the motion of this, simulating this assembly, you do something called a motion study, and you'll find the option over here. Now in this case I've pinned it to my toolbar. You'll find it in the drop down in case it's not there over here. Now, when I create this motion study, I just left clicked on it. Now it'll ask me to select some joints to animate. Now in this case, I just have this one joint. So when I click it, you'll find this little line that comes over here. And what Fusion is telling me to do is to add, let's say, some checkpoints in the motion study, where I know, where you could say I'm telling Fusion that, okay, at this point, let's say uh, let's say I'm measuring this with respect to time, right? So at t equal to 10 seconds, I want the joint to be at this configuration, or let's say this angle. And at t equals to 25, I want it at this angle. So let's say I do this. And so I just clicked on the graph over here. Yeah. And you'll notice that I can change the angle. So let's say I make this 80 and I press enter. You'll notice that the graph has changed. So this is essentially going from its initial position to 80 degrees in this much time. And I can add, say, another position, let's say -80. So I can add as many checkpoints as I want, let's say 150, and so on. So this looks like a nice, good graph that we could do. And after you've determined what positions you actually want to see, you can use this play button now. Now you'll notice that it's moving a bit too fast, and that is because the speed over here is a bit too fast. So I'll just pull this all the way to the left. And this is how you do a motion study. Now, obviously, this is very simplistic, but this actually is very useful for when you have multiple uh, components in assembly with multiple parts. So what happens is you have this line for every single joint. So let's say I have another joint over here also. So that the motion study curve for that joint would show up as a blue line, and I can select checkpoints for that too. And it's a good way to see, or you could say gauge, how easily your assembly is moving, and kind of graph or visualize how this stuff is actually moving around. And there are many more other uh, options over here too. Like, I, instead of doing just from start to end, I can also loop it, or I can also go back and forth. So I'll just press OK for now. And this is this is the entire workflow of how to make an assembly and do motion study. Now there are a few other miscellaneous things that I want to cover. And first off is, if you see the assemble drop down, you'll notice a lot of things like as built joint, joint origin, drive joints, etc. And I'll tell you what each of these mean. Now, when we created a joint using the simple joint command, we explicitly defined like where the joint is supposed to be placed, and Fusion did it automatically, as in it actually forcibly brought the bodies together. Now, sometimes it so happens that the joint that we want to place, it doesn't get detected by Fusion that easily. So, or it's a pain trying to get that joint to like fix itself or like get detected by Fusion. So one workaround along that is to make an as built joint where you physically like kind of align the two parts together, and then you create the joint. And what that does is exactly like a normal joint, but with this one additional feature that Fusion is not going to bring the bodies together. Rest everything else is the same. And as for drive joints, in this case, what I was doing was I was explicitly like moving this portion around, this part around the joint around. But in case you want to say give a speed to the, or you could say not just speed, in case you want to define a specific angle also to this joint that you're making, you can use the drive joint feature and also do this. You can explicitly set an angle like that. And there are many, and yes, the most important one is this contact set option. Now you'll notice that there are two similar options. One is enable contact sets and other is enable all contact. Now the enable, now before that, I'll just tell you what contact sets are. You'll notice that when we had this flipped pipe which was clipping through the plate, in that case, Fusion automatically assumes that there is no, you could say, contact that is being detected between the two bodies. It's like you put your hand through the table, but you it's like the universe doesn't detect that your hand is actually like in contact with the table, so your hand just passes through. Or in, say, games, you get those glitches where your character is like stuck inside a wall or a couch, something like that. So what is happening there is a contact set is not being made, or in other words, there is no contact that is being defined between this pipe and this plate. When you enable the contact option, what it does is, like the name suggests, it enables all contact interactions between this part and this. So let's say you have, let's say this is something that you can try out at home. You can make a simple block over here and fix it to this hole. And when you enable contact sets, you'll notice that when this pipe will hit that block, it can't go any further. Like without the contact set, it just phase through the block. But with the contact set enabled, or with all contact enabled, it won't be able to pass through. Now, what I just explained was the enable all contact option. Now, contact sets is a more generalized version of enable on contact, in that in the first option, enable all contact, it enables contact for all parts and bodies without fail. But let's say you just want to focus your, let's say your contact, you could say study how the things are interacting. You want to focus it on just one specific portion of the parts. So for that, you can enable contact sets and uh, specify what specific parts you want contact to be enabled for. Like in the example that I just told you about, the box and the plate. Now I can enable a contact set between the pipe and the box, but I can choose not to enable contact between the box and the plate. So the pipe will stop when it hits the box, but I can move the box around and it'll phase through the plate or whatever. So this is another way of you say defining contact between the assembly. And when it comes to motion studies, there is nothing, it's actually very simplistic, there's nothing much to it. If you want to do a more advanced study, like something with velocities and acceleration and stuff, unfortunately that isn't a feature, like a inbuilt feature rather, in Fusion C60. You will have to make or you will have to use maybe a more advanced software. Like in case most MITians who are maybe in mechatronics may know of this software called, say, a mech analyzer or robo analyzer. So with that, I essentially does what I'm talking about over here, a motion study, but a more advanced version where you have accelerations of the links, velocities of the links, etc., etc. But for our purpose, like as a mechanical designer, we don't really care much about that at the moment of actually designing the part. So that is the reason why the motion study capabilities are restricted. And yeah, uh, coming, I'll now show you the other method of making the assembly. What I did right now was making the entire assembly in a different, let's say, file. Now I can also kind of carry this same principle in body one. So I can, instead of like making a different file, I can directly import body 2 here also. And I can do the same things that I just did for the main assembly file. What the entire assembly thing and the motion study thing. All right. So since we have a bit of time, I thought I'll just show you a bit of a sneak peek into the other you could say options that Fusion C60 has, which of course we'll be covering in the intermediate workshop. Now in, let's say, in tools, you'll find a lot of options over here. Like for example, measure. Now, with relation to assemblies, let's say I want to measure the distance between this and this. So it's a good way to for me to actually like kind of find out the exact distance between, let's say, that hole and this hole. Or let's say I want to do the same thing with this thing. I want to find out the distance between these two holes. So 160 mm or 132 mm. Now you'll notice that there are two values over here. Now this 160 is center to center and 132 is edge to edge. You can notice it by the two sets of arrows that are there. And I can try this on other stuff as well. Like let's say this 10 mm. So stuff like that. And now this interference thing is related to what I talked about earlier, the no clipping portion. And this, like it says, it reports the interference between the selected solid bodies or components. Now, in case you're not entirely sure whether, like I said, I this pipe is kind of you could say very much almost cutting into the plate. Now, I may not be able to confirm it visually, but I can use this interference tool and say whether it's actually happening or not. Okay, so in this case, it's not working. That's probably a fusion hiccup, but you can try this out for yourself at home. And this is okay. Now, draft analysis is more of a practical, you could say, consideration. Like I mentioned, you'll have to include some room for error in your actual design. And draft analysis and accessibility analysis are more towards the camp portion of things, which we'll be covering in the immediate workshop. And what it actually does is, in case any of you have seen a CNC in action, you'll know that it has like a drill bit that actually does the job, like it cuts the material and all. Now, depending on the part that you're actually making, like in this case, for like speaking from experience, this is a very simple part to like manufacture in a CNC. It's very simple design, very easy to access and all. But in case you're making some really exotic shapes, like if say you're working with the surface modeling tools, right? Obviously you'll have some very weird shape that will come out. Now that might not be perfectly manufacturable by your standard CNCs, and using these two tools is a good way to know that. And this section analysis is like the description is showing. It shows you an entire cross section of your entire design. And this is in case you want to actually include some hollows inside an object. So you can make a section view, and on that section you can create a sketch and do whatever you want in that plane. Okay, so are there any other questions? Okay, so thank you for coming today. Well, it was a very short session. And now that you've made this assembly, whatever you've done, I would recommend you try to play around with the joints or the various assemble tools that are there. And like I showed, the physical material and the appearance tools. Yeah, something that I forgot to mention, in let's say body one, any part that you're making, I forgot to mention that there are two separate uh, tools for appearance changing. One is you're actually changing the physical material. Like in this case, let me just, let's say this is glass, the material is glass, right? Now, if I go to the properties of this part now, you'll notice that the physical material and all the properties and everything has changed. Now, in case, now I know the material is glass, but let's say just for ease of viewing, I want to change the appearance of the part. Now I can either use the letter A on the keyboard to bring this up, or like I just showed you, I can use a drop down. Now in this case, I can use uh, other colors. It's kind of like coloring an object, but the actual object is still glass. Like if I now show the properties of this object, you'll notice that the physical material is still glass and the appearance is now gold because I just put the appearance as gold. And why this is important is uh, let's now this is more with relation to day 4, which we are going to do tomorrow, where the assembly that you made or the parts that you made, we'll be showing you how to uh, show animations of the parts or the assemblies that you made in a, you could say, commercial style. Like you've probably seen phone commercials, right? So they have those cool animations where the phone is turning around and all. So we'll show you how to do that, and also we'll also show you how to create photorealistic renders of the parts that we've made right now. You'll notice that obviously, I mean, the thing is gold. I mean, the appearance is supposed to be gold, but well, it doesn't look like gold, does it? So that's because it's a very simplistic visualizing that Fusion is doing to save up on computer uh, resources and all. But when you make a photorealistic render, like based on all the lighting settings and all, which we'll be talking about tomorrow, you will be able to actually bring out the gold shine in this, and it'll actually look like this is a gold plate. So do come tomorrow for this session. And actually, apart from what we're talking about, like the animations and the rendering, as an individual designer, it's very important for you to know how to, like, design aside, well, of course you need to know how to design, but more often than not, what really you could say gives you visibility as a designer is not the design itself, but how you present it, like how you present it to the outside world. Or let's say you are seeking, let's say you're a startup, right? And you have this cool new idea that you just designed, but how do you actually present it to investors in a very good, like a very fancy way, like you see on TV? So using the animations and the rendering photos and everything that you'll show, you'll be able to paint a very good picture of what your design is actually supposed to be, and it'll garner you a lot more attention and visibility. So with that said, thank you for coming today, and we hope to see you tomorrow.